Good morning, respected Professor Namrata Sharma Madam, Honorable Director, respected Coordinator Dr. Surendra Kumar Malviya, and the whole team who are working day and night for us. I am Dr. Raja Ghosh from Department of Chemistry, Sri Singh College, and my e-content on Qualitative MO as I am undergoing 4th FIP organized by the UGC HRDC Davv Indoor. So I am from Sri Singh College, an old college, but every year we are trying to produce good student as much as possible. Like our principals are felicitating this student. This is our chemistry department student, got chance in the IIT NIT Rourkela. Also, in every year from TCS Tata Consultancy Services, every year a lot of students get chance from our college, and famous singer Arjit Singh is also from our college itself. So let's come back to our main issue of discussion. So why need molecular orbital theory? What is qualitative MO theory? Atomic orbital to molecular orbital, bonding and anti-bonding interaction, introduction of sigma, sigma star and pi orbital, frontier molecular orbital theory. So Chem HT2, our full paper with 4 credit, contain 3 chapter. So first chapter is the basic of organic chemistry, bonding and physical properties. 18 lectures are allowed for this. So we may use 8 lecture for this. So why molecular orbital theory? The valence bond theory, basically extension of the Lewis structure that consider the overlapping of the orbital to create bonds. But it is limited. Why? As it does not explain the molecular geometry of the molecule very well. This is where hybridization and the molecular orbital theory comes into place. So, qualitative MO theory we'll read about. Quantitative we'll read in the later higher classes. So, qualitative MO theory is the way of building up a simple picture of the molecular orbital of the molecule using a few basic rules. The ideas discussed in this section will allow us to make back of the envelope prediction and allow us to interpret the result from the more sophisticated calculations, which is not easy. We start with the simple principle that atomic orbitals can be combined to give molecular orbital. In building up our combination, the overlap between atomic orbital is determined by their energy orientation and size. In the simple example of the hydrogen molecule, the two 1s atomic orbital are combined to give 2 molecular orbital. So 2 atomic orbital combined will give 2 molecular orbital. In the same way, if 4 atomic orbital combined, then 4 molecular orbital will get. As the energy orientation and the size of the 1s atomic orbital on each hydrogen atom are the same, that is identical, so ground state of the hydrogen molecules of the 2 electron present occupy the bonding molecular orbital theory. So hydrogen is a stable molecules with bond order of 1. So bonding below 1 is the bonding and above 1 is the anti-bonding, denoted by 2 different color. And what will be the bond order then? 2 minus 0 by 2. So 1. So 1 sigma bond is present in the hydrogen molecule. We are concerned with the combination of atomic orbital to form new molecular orbital. This new orbital arises from the linear combination of atomic orbital to form bonding and anti-bonding orbital. The bonding orbitals are of lower energy than that of anti-bonding orbital, so they are first to fill up. By figuring out the MO, it is very easy to calculate the bond order. Like previously we calculated hydrogen bond order 2 minus 0 by 2 equal to 1. So bond order 1. Bonding and anti-bonding, introduction of sigma to sigma star. So when bonding will happen, when sigma bonding you will get, then automatically simultaneously you will get sigma star anti-bonding. So when sigma bond will form, we should to know this. Like when frontier overlapping happen, close overlapping, strong overlapping happen, like between S and S, S and P, PZ and PZ through their axis, dz square to dz square, etc., etc. Many examples are here. You people should practice here in your copy. So here we'll get sigma bond. So bonding and anti bonding interactions. So please enjoy this video. So in case of hydrogen, 1s atomic orbital combined with 1s atomic orbital and forms bonding orbital and anti-bonding orbital. And bonding orbital, anti-bonding orbital are equidistant from the center of gravity or the barycenters. So how much it is stabilized? Equally it is destabilized. And I want to mention that this one is known as HOMO, highest occupied molecular orbital, and top one is known as the LUMO, that is lowest unoccupied, because this is not occupied or unoccupied. That means theoretically some more orbital are there, but this is the lowest unoccupied. That is why that is the LUMO. Top one is the LUMO. And when pi bond will form, when partial overlapping will happen, then pi bond will form. That means chemistry student, strong interaction, sigma bond, chemistry student, physics student, weak interaction, pi bond. Simple example. So let's come to the new concept, frontier molecular orbital theory. So frontier interaction we already explained, frontier bonding we already explained. So in 1952, Japanese scientist Kenichi Fukui published a paper in the Journal of Chemical Physics, a molecular theory of the reactivity in aromatic hydrocarbon. Widely criticized at that time, unfortunately, later his work was recognized. As a result, he got Nobel Prize in 1982 with Roald Hoffmann. And I want to, as my TS student, I want to tell you people that our principal sir's one of the co-workers, his book was praised by Roald Hoffmann. So what Fukui said, and I also want to share this fact that the Fukui was the first chemist from the Asian continent to got Nobel Prize. Like Rabindranath Tagore was the first person to got Nobel Prize in literature from Asian continent, that we know. So Fukui's own work looked at the frontier orbital and in particular in the effect of the HOMO and LUMO on reaction mechanism. So already we have learned about the reaction mechanism, which led to it being called frontier orbital theory or FMO. Fukui understand that a good approximation for the reactivity could be found by looking at the frontier orbital HOMO-LUMO. This was based on the main observation of the molecular orbital theory as two molecules interact. The occupied orbitals of different molecules repel each other at the both of the negative charge electronic cloud. They will repeat each other. Then positive charge of one orbital attract the negative charge of the other. This is the basic fundamental theory we know from our childhood. The occupied molecular orbital of one molecules and the unoccupied orbitals of the other interact with each other, causing attraction. Causing basically attraction. Actually, interaction is a broader term. Interaction maybe attracting, maybe repulsive, right? So interaction. So we say that students, please interact with your peers, interact with your teachers. So we expect that good interactions, attractive interactions. So again, please relax, enjoy and learn from this YouTube video also. And if any problem, I'll explain you people. So again, thanking you very much. Thanks to Honorable Director Madam, Honorable Coordinator and their whole team, and our Honorable Principal Sirs to give me chance to do this, participate in this great program. And thanking you all, one and everyone, respected teacher, faculty, and all students who listen to me very sincerely, carefully. Thank you again, thanking you very much.